Welcome once again to Academic Solution Physical Science Grade 10 with me, your usual tutor, Martin Otin Ado. I'm happy to be with you guys here today because today we are going to be talking about a very important topic that matters the real life of everybody. And which topic are we going to talk about? We are going to be discussing about electricity. We are going to be discussing about electricity. But before we come to look at electricity, we must always note that the reference book that was used for this video is the Level Up by Academic Solution. Now, what is this Level Up book? This Level Up book by Academic Solution, it's very simplified, it's very interactive, it contains a lot of past questions as well as the memos to the past questions. So please make a point with Academic Solution and get yourself a copy of this book because it makes your physical sciences very easy. Now let's go to our topic for the day. That is what we call as what? Electric circuits. I believe all of us use electricity in our daily life. We use it in the industries, in our homes, for cooking. Almost every part of our life we can never go without electricity. So it's very important when we talk about electricity. Now this video is just going to focus on the introductory aspect of electricity, whereby we are going to try to define some basic principles behind electricity. Then in my previous video we are going to also look at some other things that are related to electricity. Now before we even go into it, let's quickly ask ourselves, what is electric circuit? What is an electric circuit? An electric circuit is a closed path with no space along which an electric charge flow and is being powered by an energy source. So if you say an electric circuit, we simply means that the path must be closed. Okay, it must have a closed path. And what is this path? Because the charges are going to flow along this path, and before the charges are going to flow, they must be pushed or they must be moved by a source of energy. And normally in our simple circuit, our source of energy which pushes the charges when which is at rest is a battery. Right? When you take any simple electric circuit, it contains certain things that we normally see. Examples of them are the light bulbs, the battery, the switches, the voltmeter, the resistors, which we are going to be discussing about them. Now when you put all these things together, that is what we call it as as the component of an electric circuit. Sometimes diagrammatically we can represent an electric circuit on paper, whereby we use what we call as circuit diagrams. So once our electric circuit has all the components, it has the battery and all the components, all the things that are supposed to be in place is there, and then our current can start to flow. We will look at current later on. But what we need to know in this video is we want to look at the definitions for the basic things that we need to know. The basic definitions that we need to know, the first one is what we call as potential difference. What is potential difference? When we say the potential difference in an electric circuit, what does it mean? Now remember, whilst I was explaining, what I said is that let's think about a charge as it is at rest. Our circuit is complete. Okay, the switch is it's not an open switch. Okay, remember, a switch is used for to control the flow of charges. So before a charge will flow, it needs some kind of of a work to be done on it, to push it, to move it, and for move it from where to move from the to the battery is the one which does that kind of work on the charges, because the battery has what we call as a potential energy, which can change it to what we call as electrical energy. So remember, we already know that a charge is measured in what we call as coulombs. So if there is a work that needs to be done on these charges so that they can be able to move, now that work which needs to be done on the charges is what we call as what? Potential difference. So if you look at here, what I've written here is that potential difference is the work done per unit charge, and it's expressed as what you can see is W over Q, where this one represents what? The work done, and this one represents what? Per unit charge. Now it has its unit, just like any quantity in physics has its unit. It also has its unit, which is in what? In volts. Now we define volt as what? As 1 joule per coulombs. So potential difference, normally we represent it with V, and then we call its unit as what? As volts, and its symbol that we will be using it's what we call as what? As the volt. Now remember, we said that is the work that needs to be done to drive the charges. Okay, so for every unit charge that is being driven, that is what we express this in terms of what? As potential difference. Now to measure the potential difference of a what? In an electrical circuit, we use an instrument which is called the voltmeter. So if you look over here, I'm showing an example of a what? Of a voltmeter. What normally we do with a voltmeter is that you connect one end of the voltmeter. Look at what is happening here. I will connect this end here of the voltmeter to the battery, which is already with the charge which are flowing through what? The circuit. Then I connect this charge, this end also over here to the another end of the what? Of the circuit, that's the battery. Okay, so this is the voltmeter which showing us here. It says a voltmeter is an instrument which is used to measure the potential difference between 2 points in an electrical circuit. So if I want to measure the charge, the work that was done on the charges per unit charge, we use this instrument that we call as the what? As the potential, the voltmeter. Now quickly, let's look at what is called EMF of a battery. Now there's a difference between the potential difference and there's a difference between the EMF. I believe after this one you can be able to differentiate between what is an EMF and what is a potential difference. The difference is just this: the EMF is what you measure on the terminals of a battery when it is not in a complete circuit. It means that when the battery is there and it's not in a complete circuit, that's what you can be able to measure from it using the same voltmeter is what we call as the what? The EMF. Okay, now when we're trying to measure an EMF, what we are trying to achieve is that we want to know the maximum amount of work per unit per coulombs of charge a battery can drive charge from one terminal of the circuit through the circuit to what? To the other terminal. Because remember, we said this battery is the one which is going to push the charges so that the charges move through the what? The electric circuit. So if you are measuring the EMF, you want to know what is the work that this battery can be able to do to what? To drive it. So the difference between the EMF and the potential difference is very simple. One is what? When it is connected, that is the potential difference, and then when you measure when it is not connected, that is what we in a complete circuit, that is what we call as the what? The EMF. Now let's look at what is called a current. Okay, once our battery is fine, our circuit is connected, then it means that the charges start to what? They start to flow, okay, through the what? Through the complete circuit. So when they start to flow, then we get what we call as our current, which is here. So if you look at what has been defined here, we said current is defined as the rate of flow of what? Of charges, the rate at which the current is flowing. Okay, then we expressing current, which is we represent it with what? I is equal to what? The charge per what? The change in what? In time, which is here. So that's why we have defined it as the rate of flow of charges. Now the direction of a current is from the positive terminals of the battery to the what? To the negative terminals of the battery. Okay, this is what we refer to it as a conventional current. So always the direction goes from the where? From the positive terminals of a battery to the what? To the negative terminals of a battery. And current is also measured in what we call as what? Amperes. Okay, where you present it with what? With A, using an instrument that we call as the what? The ammeter. Okay, so if we want to measure the current in a particular complete circuit, we use this instrument which we call as the ammeter. Okay, so we are going to see how the ammeter, this is the picture of the ammeter that I'm showing you here, which is being used to measure the flow of the charges in a complete circuit. Now we define these amperes here as the current in a conductor, and then 1 ampere when 1 coulomb of charge passes through the conductor per second. Right, now when we want to connect and look at the current here, we use what we call as the ammeter, which I already said already. Now the ammeter is an instrument which is used to measure the rate of flow of electric charge in a circuit. Since one is interested in measuring the flowing through a circuit component, the ammeter must be connected in series. We will come and look at what is called a series connection and then a parallel connection. But what it simply means is that it must be measured with the same path. Okay, this is what the ammeter which has been measured here. So when you put the ammeter here while the current is flowing through, this is a load which has been put here, it's a resistor, right? Then we can be able to measure the current through it. Now quickly, let's do some calculations with respect to whatever we said here with regards to with regards to current. Remember, we said the current is the charge per watt. This is what I'm talking about here. Remember, we said the current is the charge, is the rate of flow of charge, and it can be expressed using this one. So quickly, let's go and look at some examples of it here. An example, we said an amount of charge equals to 45 coulombs move past through a point in a circuit in 1 second. What is the current in the circuit? Just like we discussed on, anytime you have a question, try to put and look at what has been given to you. Okay, you analyze the question and say, what has been given to me in this question? You underline them or you list them down to say, this is what I've been given. Now let's look at our question here. What did they give us here? They gave us a charge. Okay, they gave us a charge here. They went on to tell us as to when the charge passes through it's 1 second. And then what are we asked to find here? We said what is the current. So we don't know. This is the current that we are going to be we don't know that we are looking for. So if you look at how I've put in this analysis of the question here, it's just the same thing that I've explained. We are given an amount of charge and time and asked to calculate the current. We know that current is the rate at which the charge moves past a fixed point in a circuit. So we have all the information we needed. Yes, the information that we needed is what I just underlined with the pen over there. So it means that now we need to calculate for the current, and we know that current is always represented with I, and then the charge over the time which is always measured in seconds. Current charge is measured in coulombs. So we just slot in, or we just substitute the values that have been given. My charge was given as 45 coulombs, right? All divided by 1, and any number divided by 1, we already know that it gives us the same one. Now when this gives us the unit for this as coulomb per second. But remember, we measure current, as we said, in amperes. So we put the result here, the final result, which is 45 amperes. This ends our introductory aspect to electricity. Quickly, let's go back and see what we have learned so far. We've learned about EMF, we've learned about current, we've learned about the potential difference. Now the difference between all these three quantities, all these three that I've spoken about, is very simple. The potential difference is the work done to move a charge. Okay, now the EMF is the what we said is the potential difference when the battery when it's not connected in a complete circuit. And then the current, we said, is is defined as the rate of flow of a charge. And we have been able to use the current to do some calculation. We've also looked at the various instruments that are being used to measure all these things. Current with an ammeter, EMF with a what, with a voltmeter, which is also connected, must be connected in power to the voltmeter. Then we have potential difference also, which is being measured with a what, with a voltmeter as well. Now until I come to you again with another video, I will say keep on sharing the video, and always remember, please try to get our level up by academic solutions, and your physics is going to be very simple. Keep sharing the video, guys. Until we meet again, keep enjoying physical science. Science is very good. Thank you very much.